Gazing upon the nocturnal heavens reveals a tapestry of luminous points piercing the void. Yet consider this paradigm-shifting insight. Virtually all stars discernible without aid originate from a solitary galactic entity, our own Milky Way. This stellar metropolis is but a single component within an expansive assemblage comprising around 50 galaxies, designated by astrophysicists as the local group. Far from tales of remote celestial edifices spanning eons of light travel, this narrative concerns our immediate astral vicinity. These entities reside at distances permitting intricate scrutiny, where their gravitational influences impinge upon us, and certain trajectories forecast impending mergers. The local group encompasses approximately 10 million light-years, a unit denoting the span traversed by electromagnetic radiation in a terrestrial atom at 300,000 kilometers per second, equating to roughly 9.46 petameters. Thus, the expanse translates to an incomprehensible 94.6 sextillion kilometers. To contextualize this immensity, envision compressing the observable cosmos to Earth's diameter. The local group would approximate a modest domicile. This represents a minuscule enclave amid the universal expanse. Dominating this domain are three prominent spiral systems. Foremost is the Milky Way, harboring an estimated 100 to 400 billion stellar bodies, accompanied by exoplanets, satellites, minor rocky aggregates, icy wanderers, and immense nebulae of interstellar medium. Classified as a barred spiral, it features a linear core from which helical extensions radiate. Our solar system resides 26,000 light-years from the nucleus, nestled in the Orion Cygnus branch. Analogize the Milky Way to a galactic megalopolis. The hub teems with stellar density, while peripheral zones, including our locale, exhibit sparser distribution. The system's breadth measures 100,000 light-years, with a disk thickness of merely 1,000 light-years. Proportionally, if reduced to a platter scale, its depth rivals a membrane's thinness. Originating 13.6 billion years post-Big Bang, it has accreted mass via cannibalistic assimilation of lesser companions, gravitationally disassembling and incorporating their constituents. Next looms Andromeda, or M31, the preeminent member, positioned 2.5 million light-years distant. On astronomical metrics, this proximity renders it virtually adjacent. Under pristine conditions, it manifests as a hazy blotch to unaided vision, photons departing thence when Homo sapiens' forebears fashioned rudimentary implements. Encompassing 1 trillion stars, Andromeda exceeds the Milky Way's mass by a factor of 2.5, with a disk diameter of 220,000 light-years, double our own. It, too, is barred, albeit with a subtler central feature, and hosts a colossal void at its core, massing 110 to 230 million solar equivalents. Completing the triumvirate is the Triangulum galaxy, M33, at 3 million light-years. As the diminutive spiral among the trio, it lacks a bar, with arms emanating directly from the nucleus. Housing 40 billion stars across 60,000 light-years, it compensates for stature with aesthetic splendor. Sharply delineated arms punctuated by vibrant stellar nurseries. Proportionally, its star genesis outpaces its larger counterparts, fostering nascent luminaries with vigor. Encircling these behemoths are myriad subordinate structures, predominantly dwarf variants. These minor systems vastly outnumber their grandiose kin and illuminate core principles of galactic genesis and maturation. Dwarfs manifest in diverse morphologies. Elliptical types display ovoid smoothness devoid of features. Spheroidals resemble amorphous puffs. Irregulars exhibit disordered contours amid ongoing stellar birth. Each subclass narrates distinct evolutionary sagas. Universally, dwarfs are permeated by dark matter, the enigmatic component comprising 85% of cosmic mass. Impervious to electromagnetic interaction, its presence is inferred via orbital velocities. Stellar motions exceed expectations from luminous matter alone, necessitating unseen gravitational augmentation. In spheroidals, dark-to-visible ratios soar to hundreds-fold. Extreme ultra-faint cases approach 3,000 to 1, rendering them dark matter agglomerates sparsely adorned with stars. Such configurations serve as pristine arenas for probing this elusive entity, with instruments scanning for gamma emissions from hypothetical particle collisions, yieldless thus far, yet pursuits endure.
Most dwarf spheroidals are relics birthed over 10 billion years hence, ceasing stellar production eons ago. Their populaces comprise aged crimson giants bereft of azure youths. Mechanisms quenching this activity likely converge. Feeble gravitational retention permits supernova blasts from initial massive stars to expel residual gas, depriving subsequent generations. Primordial cosmic radiation heated protogalactic media, impeding collapse during reionization, a phase when nascent luminaries and quasars ionized intergalactic hydrogen via ultraviolet flux. Proximity to titans induces tidal stripping of stars, ram pressure ablation of gas by haloplasmas, and radiative inhibition of condensation. Consequently, these fossils encapsulate primordial chemistries, enabling spectrographic dissection to chronicle nucleosynthetic progression from Big Bang's hydrogen-helium primacy to contemporary elemental diversity. The Milky Way commands 50 to 60 known attendants. Iconic are the Magellanic Clouds, visible hemispherically southward as nebulous fragments. The Large Magellanic Cloud, at 160,000 light-years, boasts 30 billion stars over 14,000 light-years. Its small counterpart, at 200,000 light-years, holds 3 billion. Both irregulars burgeon with stellar infancy. Initially deemed perpetual captives, refined kinematics suggest a maiden traversal, destined for gravitational dismemberment and assimilation, evidenced by trailing gaseous tendrils. The Sagittarius dwarf spheroidal endures active dissolution, positioned 70,000 light-years oppositely, having endured multiple disk transits. Each incursion sheds stellar arcs, encircling our galaxy in intricate loops. These perturbations propagate undulations, potentially inciting stellar births or perturbing heliocentric paths, perhaps influencing our system's galactic circuit 300 million years prior. Over gigayears, it will disintegrate, its legacy mere chemical imprints. Fornax, at 460,000 light-years, harbors 6 anomalous globular clusters, dense stellar spheres of ancient vintage, 10 to 13 billion years old, containing multitudes in compact volumes. For Fornax's mass, this abundance implies a heftier progenitor, eroded by orbital attrition, clusters persisting as resilient vestiges. Sculptor, discovered 1937 by Harlow Shapley at 290,000 light-years, shelters millions of archaic stars, quiescent for 10+ billion years. Its utility lies in elemental assays, unveiling early cosmic compositions. Andromeda governs at least 35 subordinates, notably M32 and M110. M32, a dense elliptical proximate at 22,000 light-years from Andromeda's core, packs billions into confined space, hinting at a denuded spiral remnant post-encounter. NGC 147, a spheroidal at 2.7 million light-years, spirals inward, fated for disruption. Autonomous entities dot intergalactic voids. IC-10, an irregular at 2.2 million light-years, surges with stellar creation. IC-1613, at 2.4 million, engages ambient gases for birthing triggers. Sextants A and B, peripheral at 4 to 5 million, exhibit moderate genesis, with A elongated from historic tugs. Ultra-faint dwarfs unearthed recently border galactic definition. Segway 1, 2006, 75,000 light-years, nearly 1,000 stars, and kin like Segway 2, Willman 1, Boakes 1 and 2 possess scant luminaries, but velocity dispersions affirm dark dominance, 3,000 to 1 ratios. These primordial relics, forged post-Big Bang, endured singular stellar bursts 13+ billion years ago, their paucity of metals echoing inaugural supernovae. Humanity's galactic awareness dawned gradually. Pre-20th century, hazy apparitions were deemed intra-Milky Way nebulae. Edwin Hubble's 1923 Hooker telescope resolutions of Andromeda's Cepheids, pulsars linking period to luminosity, yielded distances transcending our bounds, birthing extragalactic cosmology. Hubble's 1936 treatise catalogued a dozen locals. Mid-century tallies reached 24, end-century 40, now 50 to 60. Detection demands meticulous imaging of expansive fields, algorithmic sifting for stellar clusters, spectroscopic validation of cohesion and proximity. Surveys like Sloan Digital Survey, early 2000s, unearthed ultra-faints. Dark Energy Survey amplified. Vera Cruz Rubin Observatory's Legacy Survey of Time anticipates dozens more.
Hubble refines 3D mappings via Cepheids. Gaia charts stellar kinematics for billions, elucidating orbits and dark distributions. Radio arrays trace 21-centimeter hydrogen for gas dynamics. ALMA probes nascent clouds. JWST pierces infrared veils for obscured births and ancients. Adaptive optics sharpen ground views. LIGO, Virgo sense merger ripples. Neutrino traps hunt supernova ghosts. Multimodal synthesis paints holistic portraits. 2020 Gaia data unveiled the Enceladus merger remnant, a 10-billion-year-old dwarf stellar sausage upending quiescent Milky Way narratives. Andromeda's halo bears merger scars like the southern stream, tidal archives yielding progenitor insights. Gravity orchestrates, group-scale tethers to barycenter, Andromeda biased. Galactic fields ensnare satellites. Intragalactic bonds orbit stars. Rotational anomalies, peripheral velocities defying luminous mass, unveiled dark halos, spherical sheaths outreaching visible realms. Milky Way's totals 1.5 trillion solar masses, 90% dark. Candidates? WIMPs, lab-hunted via collisions, axions, ultralight, primordial voids. Radiation exerts minor thrusts, compressing or expelling media, modulating births, pivotal in dwarf's quiescence. Magnetism, dynamo-generated, tempers collapses, regulating rates. Tidal distortions elongate dwarfs, spawning persistent streams. Mutual dwarf encounters spark bursts. Gaseous exchanges via stripping or accretion fuel or starve evolutions. Ram pressure denudes traversing satellites, quenching spheroidals. The local group fringes the Virgo supercluster, Laniakea, spanning 520 million light-years, gravitationally tugged at 600 kilometers per second towards the Great Attractor, a density nexus, and Shapley beyond. Hierarchically, group encompasses subgroups around majors. Subgroups host galaxies with internal architectures. Galaxies harbor stellar systems. Timescales elongate upward. Stellar evolutions span mega or giga-years. Galactic circuits hundreds of millions. Group dynamics eons. Cosmological simulations incorporating gravity, hydrodynamics, stellar feedback, magnetism, rays, validate lambda CDM, dark energy plus cold dark matter, replicating observations yet grappling discrepancies. Missing satellites, over-predicted halos, perhaps starless or undetected. Core cusp, cuspy sims versus core data, maybe feedback flattened. Hierarchical assembly posits bottom-up mergers, evidenced by streams. Andromeda approaches at 110 kilometers per second. Models forecast 4 billion-year merger, 50% certainty, yielding elliptical Milkomeda, Triangulum possibly incorporated or ejected. Black hole coalescence radiates waves, satellites scatter or assimilate. Cosmic acceleration via dark energy contracts horizons. In 150 billion years, only local remnants visible, distant galaxies redshifted beyond reach. Trillions hence, stellar exhaustion yields cold remnants, hawking evaporating voids. Life's ubiquity? Milky Way's billions of worlds include habitable zones for liquid H2O, life's solvent. Extending to trillions local stars, even fractional emergence implies multitudes. Prerequisites? H2O, abundant H/O. Energy? Stellar, chemical, or geothermal. Organics? Stellar forged C/N/O/P/S. Earth's rapid biogenesis suggests commonality. Interstellar dialogue? Andromeda round trips span 5 million years, intramilky feasible via SETI radio scans or biosignatures O2/methane spectra. JWST probes exoplanet airs for hints. Local insights, galactic diversity reflects formative variances. Interactions propel change. Dwarfs' prevalence informs halos. Orbits gauge masses. Histories trace POP3 behemoths. Cosmic web tugs motions. Distance ladder anchors expansion. Reionization fossils in ultra-faints. Relativity, simultaneity, illusion, universal laws affirm Copernican mediocrity. Forthcoming, Rubin hunts members, ELT resolve stars, Roman infrared surveys. Queries, globular origins, quenching triggers, dark distributions, merger fates, extraterrestrial existence. Structurally, galaxies comprise bulges, dense ancients, disks, gaseous births in density waves, halos, old eccentrics plus dark sheaths. Dwarfs simplify sans disks. Stellar chemistries chronicle enrichment, POP3 pristine, exploding to seed heavies, POP2 low metallicity. Sun's 2% heavies enable solidity. Ratios O/Fe timestamp supernovae types. Halo diversity fingerprints accreted dwarfs. Star formation, inefficient collapses, 1 to 2% yield, modulated by gas stocks, efficiencies. Spirals steady, bursts merger-induced, irregulars proportional vigor, spheroidals extinct. Populations decode timelines, blues nascent, reds senescent. Supermassives lurk centrally, SGR-A*, 4 million solar masses, orbited relativistically. Andromeda's heftier. Seeds, direct collapse or merged stellar remnants. Feedback quenches via energetic outflows. Gas cycles, accretion, hot or cold modes, replenishes. Outflows, winds or explosions, deplete. Fountains recycle. Intergalactic hot plasmas strip satellites. Cosmic rays, supernova accelerated, heat or ionize, pressuring media. Magnetism, dynamo amplified, supports or channels. Metallicity gradients, inner highs, enriched generations, outer lows, late infall or dilution. Dwarfs uniform via mixing. Reionization, post-dark ages, UV bubbles ionized cosmos. Ultra-faints relics, suppressed by heating. Locals laboratory, resolved stars and kinematics test theories, environmentally diverse microcosm. Breakthroughs, ultra-faint detections via overdensities or spectra. Gaia proper motions orbitally, abundances detail evolutions. Streams map halos, radio gas stripping, infrared ancients, UV youths, X-rays energetics. Simulations evolve fluctuations to structures, subgrid star and feedback. Targeted locals refine, tensions spur physics tweaks. Cosmology ties, inflation seeded, dark constraints, histories probe early, latter calibrates Hubble constant. Dark hunts, underground collisions, gamma and neutrino annihilations in dense dwarfs. Unresolved, census completeness, dark essence, quenching mechanics, merger odds, life's prevalence. Philosophically, cosmic abode, stardust lineage, merger destiny, comprehension's triumph, collective legacy from Hubble, Shapley, Rubin, and Zwicky. Intrinsic worth transcends utility, fostering perspective, connection, wonder. Not central, yet grasping immensity. Quest endures, unveiling origins, present and future in stellar script. Gazing into the nocturnal expanse, one beholds myriad points of luminescence adorning the void. Yet consider this paradigm-shifting revelation. Virtually all those stellar beacons discernible without aid hail from a singular galactic entity, our own, the Milky Way. This vast stellar congregation forms but a single node within an expansive consortium comprising around 6 galaxies, designated by cosmologists as the local group. Far from esoteric realms eons distant, this narrative unfolds in our immediate celestial vicinity. These proximate systems permit intricate scrutiny. Their mutual gravitational interplay influences our trajectory, and certain trajectories portend inevitable mergers. Spanning approximately 10 million light-years, a unit denoting the span traversed by electromagnetic radiation in a terrestrial annum at 300,000 kilometers per second, equating to roughly 9.46 petameters. The local group encompasses a domain where light's annual journey multiplies to an astronomical 94.6 septillion kilometers. To contextualize this immensity, envision compressing the observable cosmos to Earth's diameter. Therein, our galactic assemblage would approximate a modest dwelling's footprint, a mere droplet in the universal expanse.
Andromeda's blue shift portends collision in 4 gigayears, probabilistic, birthing an elliptical Milky-Way, Triangulum possibly incorporated or exiled. Central voids coalesce, radiating gravitational undulations. Cosmic acceleration seals fate. In 150 gigayears, extra-group entities horizon-bound. Trillions hence, stellar exhaustion yields remnants amid Hawking evaporation. Habitability abounds. Milky Way's billions host zonal worlds. Group-wide, trillions amplify odds. Essentials, aqueous liquidity, energetics, organics pervade. Terrestrial biogenesis swift post-formation. If universal, life proliferates. Interstellar spans thwart Andromeda discourse, but galactic SETI scans radio biosignatures O2, CH4 via JWST. Local group insights. Size spectrum informs genesis variability. Interactions propel change. Dwarfs' ubiquity challenges censuses. Mergers chronicle assembly. Reionization fossils. Distance calibration. Relativity simultaneity. Law universality. Copernican typicality. Forthcoming. Rubin discoveries. ELT resolutions. Roman infrareds. Queries. Globular origins. Quiescence triggers. Halo masses. Merger outcomes. Galactic anatomies. Bulges. Dense ancients. Disks. Spiral waves birthing stars. Halos. Accreted relics. Dark envelopes. Andromeda's amplified. Triangulum's pristine. Dwarfs simplistic. Stellar chemistry's trace enrichment. Big Bang's H/HE. Pop 3's seeding. Pop 2's paucity. Solar 2% metals. Dwarfs' low Fe stars chronicle epochs. Ratios O/Fe time supernovae onsets. R process probes mergers. Star formation chronicles. Inefficiencies via feedback. Spirals steady. Bursts merger-induced. Dwarfs vary. Central SMBH's 4M/solar Milky Way 100M plus Andromeda feedback quells. Mergers ripple waves. Gas cycles. Accretion, hot, cold. Outflows, winds and supernovae. Fountains recycle. Intergroup medium accretes stripped remnants. Cosmic rays accelerate supernovae, heating and ionizing. Magnetics, μg, support collapses, polarize emissions. Metallicity gradients, inner enrichment, outer dilution, dwarfs homogenized. Reionization, post-dark ages, UV bubbles merge near 1 gigayear post-bang, dwarfs halts via heating. Local groups lab, resolved stars dynamics test theories, environmental contrasts, microcosmic universe. Breakthroughs, ultra-faints via Sloan, Gaia motions, abundance spectroscopies, RR Lyrae distances, streams multi-wavelengths, HI mappings, JWST ancients, UV and X-ray energetics. Simulations, initial fluctuations evolve, subgrid star and feedback, reproduce structures, tensions drive refinements, targeted local models predict observables. Cosmology linkage, fluctuation seeds, dark constraints, reionization timings, Hubble tension ladder. Dark hunts, underground collisions, gamma and neutrino annihilations in dwarfs. Unresolved, census completeness, dark essence, quiescence mechanics, merger specifics, extraterrestrial existence. Philosophically, cosmic abode, stardust lineage, merger destiny, comprehension's wonder, generational legacy, curiosity's nobility, spin-offs enrich, perspective humbles or inspires, connectivity profound, life's query elevates. Thus, the local group transcends objects. It's our existential frame, origins to destiny, humbling grandeur amid comprehensible vastness. Pursuit unveils our cosmic narrative, chapter by chapter, affirming humanity's questing spirit. Understanding dark matter detection techniques. Dark matter, an invisible substance inferred from gravitational effects on visible matter, radiation, and the large-scale structure of the universe, constitutes about 85% of the universe's matter. Despite its profound influence, evident in galaxy rotation curves, gravitational lensing, and cosmic microwave background patterns, it remains undetected directly due to its weak or non-existent interactions with electromagnetic radiation and ordinary matter. Detection efforts focus on three main strategies: direct detection, observing interactions with normal matter; indirect detection, searching for byproducts of dark matter processes; and collider-based production, creating dark matter in high-energy particle collisions. These approaches target various candidates, such as weakly interacting massive particles, WIMPs, axions, sterile neutrinos, and primordial black holes across a wide mass range from ultralight 10 to the -21 eV to solar mass scales.
Dominating this domain are three grand spiral architectures. Foremost, the Milky Way, harboring an estimated 100 to 400 billion stellar bodies, replete with orbiting worlds, satellites, debris fields, and interstellar nebulae of hydrogen and silicates. Classified as a barred spiral, it features a linear core from which curvaceous appendages radiate. Our solar abode resides some 27,000 light-years from this nucleus, nestled in a minor extension termed the Orion Cygnus arm. Analogize it to an urban metropolis, the core pulses with stellar density, while peripheral zones, akin to suburbs, exhibit sparser distribution. Diametrically, it extends 100,000 light-years, with a planar thickness of merely 1,000 light-years. Proportioned to a platter, its depth rivals a filament's slenderness. Originating 13.6 billion years post-cosmogonic inception, it accreted mass via assimilation of lesser companions, a literal gravitational disassembly and incorporation. Next, the Andromeda galaxy, or M31, reigns as the paramount entity, distanced at 2.5 million light-years, a cosmic adjacency. Under pristine obscurity, it manifests as a diffuse haze, photons embarking when hominids first wielded rudimentary implements. Encompassing 1 trillion suns, it outweighs our domain by a factor of 2.5, its expanse reaching 220,000 light-years, dwarfing the Milky Way's breadth. A barred spiral as well, albeit with a subtler central ridge, it cradles a colossal void at its heart, massing 100 to 200 million solar equivalents. Completing the triad is the Triangulum galaxy, M33, positioned 3 million light-years hence. The diminutive spiral among the Titans, it eschews a bar, with arms spiraling directly from the kernel. Hosting 40 billion stars across 60,000 light-years, its modest stature belies aesthetic splendor. Pronounced arms aglow with nascent stellar nurseries exhibiting elevated star birth vigor per unit mass relative to its peers. Encircling these behemoths orbit numerous subordinate systems, predominantly dwarf variants. These diminutive aggregates, vastly outnumbering their colossal counterparts, illuminate core principles of galactic genesis and maturation. Manifesting in morphologies such as elliptical, smooth ovoids, spheroidal, diffuse orbs, and irregular, disordered amalgams. Each subtype narrates evolutionary tales. Universally, they are permeated by enigmatic dark matter, constituting 85% of cosmic mass, inferred solely via gravitational signatures absent electromagnetic interaction. Orbital velocities within these dwarfs defy expectations based on luminous content, necessitating unseen mass, ratios soaring to hundreds, even thousands-fold dominance. Such environments serve as pristine arenas for probing this elusive component. High-energy observatories scan for potential annihilation byproducts like gamma emissions, though conclusive detections remain elusive. Predominantly primordial, these spheroidals ceased stellar genesis over a decade of billions ago, dominated by aged crimson luminaries. Cessation mechanisms likely synergize. Feeble binding potentials expel gas via primordial supernova blasts. Cosmic ultraviolet flux post-reionization impeded collapse. Proximity to giants induces tidal stripping, ram pressure ablation, and radiative suppression. These quiescent relics, compositional archives of nascent cosmos, yield insights into elemental synthesis, from primordial hydrogen-helium to contemporary diversity. The Milky Way commands 50 to 60 known attendants. Iconic are the Magellanic Clouds, visible southern apparitions resembling Milky Way fragments. The large variant at 160,000 light-years amasses 30 billion stars over 14,000 light-years. Its smaller kin at 200,000 light-years holds 3 billion. Both irregulars pulse with fervent star creation. Initially deemed bound, refined kinematics suggest a transient encounter, gravitational distortion heralding eventual disintegration. The Sagittarius dwarf spheroidal endures active dissolution, positioned 70,000 light-years oppositely, its repeated traversals yielding stellar ribbons encircling our galaxy. These incursions ripple the disk, potentially instigating starbirth or perturbing solar paths, perhaps influencing our orbit 300 million years prior. Prognosis: total assimilation over gigayears, traces enduring in stellar chemistries. Fornax at 460,000 light-years boasts an anomalous sextet of globular clusters, dense stellar spheres, ancient at 10 to 13 billion years. For its scale, this abundance implies erstwhile grandeur eroded by tidal attrition, clusters persisting as resilient vestiges. Sculptor 290,000 light-years distant, identified in 1937, comprises mere millions of antiquated stars, dormant for eons, its composition chronicling primordial elemental paucity. Andromeda oversees at least 35 subsidiaries, notably M32 and M110. M32, a compacted elliptical mere 22,000 light-years from Andromeda's core, packs billions densely, evoking a denuded spiral remnant post-gravitational evisceration. NGC 147, a spheroidal at 2.7 million light-years, spirals inward, destined for fragmentation. Autonomous isolates punctuate intergalactic voids. IC-10, a starburst irregular at 2.2 million light-years, voraciously birthing stars amid gaseous interactions.
IC1613, similarly irregular at 2.4 million, engages ambient media. Sextans A and B, elongated outliers at 4 to 5 million light-years, exhibit moderate genesis, distortions hinting historic perturbations. Ultra-diffuse dwarfs unearthed recently skirt galactic thresholds. Segu 1, 75,000 light-years, approximately 1,000 stars, and kin like Segu 2, Willman 1, Boötes 1/2, with dark to luminous ratios peaking at 3,000 to 1. Initially contested as clusters, kinematic analyses affirm galactic status via dark halos. Potentially ubiquitous, they encapsulate reionization-era bursts, elemental scarcities illuminating inaugural stellar cohorts. Humanity's galactic awareness dawned gradually. Pre-20th century, nebulous blurs were deemed Milky Way constituents. Edwin Hubble's 1923 Hooker telescope revelations resolved Andromeda's stellar populace, employing Cepheid pulsators, whose periodicity-luminosity relation yields distances, positioning it extragalactically, expanding cosmic vistas. Hubble's 1936 enumeration listed a dozen locals. Mid-century tallied 24, fin de siècle 40, presently 50 to 60. Detection entails panoramic imaging, algorithmic clustering, kinematic validation. Surveys like the Sloan Digital Survey unearthed ultra-faints, Dark Energy Survey advanced, forthcoming Vera C. Rubin Observatory anticipates dozens more via recurrent hemispheric scans. Hubble's Cepheid pursuits craft 3D cartography. ESA's Gaia gauges stellar kinematics, unveiling orbits and halos. Radio arrays chart 21-centimeter hydrogen, delineating gas dynamics. ALMA probes nascent clouds. JWST pierces infrared veils. Adaptive optics sharpen terrestrial views. Gravitational lensing and neutrino nets capture cataclysmic echoes. Gaia's 2020 revelations unveiled the Enceladus merger remnant, a substantial progenitor assimilated 10 gigayears ago, reshaping prior quiescent narratives. Andromeda's halo evinces analogous accretions, its southern stream a colossal tidal scar. Gravity orchestrates group-wide attraction toward barycenter, Andromeda biased, halo extensions ensnare satellites, intragalactic bindings sustain orbits. Rotational anomalies necessitate dark halos, Milky Way's mass tallying 1.5 trillion solar equivalents, 90% unseen. Dark matter enigmas persist, WIMPs, axions, primordial voids. Radiation pressure subtly modulates, expelling dwarf gases. Magnetics regulate collapses. Tidal asymmetries and interdwarf encounters spawn bursts. Ram pressure denudes intruders. The local group fringes the Virgo supercluster, Laniakea, spanning 500 million light-years, drawn at 600 kilometers per second toward the Great Attractor, a dense nexus, and Shapley beyond. Hierarchical assembly, stellar systems nest galaxies, subgroups orbit majors, all within the group. Timescales elongate upward, stellar evolutions in mega-anoms, galactic circuits in hundreds thereof, group dynamics in giga-anoms. Simulations incorporating hydrodynamics, feedback, fields affirm lambda CDM, dark energy accelerating expansion, cold dark matter clumping. Yet discrepancies linger, satellite undercounts, cuspy versus chord profiles. Hierarchical mergers underpin, small to large via coalescence, evidenced in streams.
Direct detection, probing particle interactions on Earth. Direct detection experiments aim to observe rare collisions between dark matter particles passing through Earth and detector materials. These setups are typically located deep underground to shield from cosmic rays and other backgrounds, focusing on elastic scattering events where dark matter imparts energy to atomic nuclei or electrons. Techniques vary based on the dark matter candidate's nature: bosonic or field-like, oceans and air, or fermionic, particle-like, W and I. Cryogenic crystal detectors use supercooled germanium or silicon crystals around 50 millikelvin to measure lattice vibrations, phonons, from dark matter interactions. Changes in surface resistivity detect these events. The cryogenic rare event search with superconducting thermometers, CREST, at Italy's Gran Sasso National Laboratory has operated since 2000, with iterations probing WIMP masses down to 160 MeV/c squared. Noble gas scintillators, liquids like xenon or argon scintillate, emit light upon energy deposition. Photomultiplier tubes capture this light, and electric fields help reconstruct events, distinguishing nuclear recoils, potential dark matter signals, from electronic recoils, backgrounds. The Xenon series at Gran Sasso exemplifies this. Xenon 1T, 3.2 tons of liquid xenon, set a cross-section limit of 4.1 times 10 to the negative 47 centimeters squared for 30 GeV/c squared WIMPs, while xenon NT, 8 tons, targets 1.4 times 10 to the negative 48 centimeters squared for 50 GeV/c squared. The LUX-ZEP-LIN experiment also uses xenon for detection. Crystal scintillators combine crystal vibration detection with scintillation. The Dama/Libra experiment at Gran Sasso searches for annual modulation in dark matter flux due to Earth's orbit through the galactic halo, though its claimed signal is debated as possibly seasonal artifacts. The SABRE project tests this in dual hemispheres, Italy and Australia. Bubble chambers, superheated liquids, freon droplets in gel, form bubbles from particle interactions. The PICO experiment at Canada's Snow Lab uses large chambers, up to 500 liters planned, to detect nuclear recoils, helping rule out certain interpretations of other experiments' results. Axion-specific detectors for ultralight bosonic dark matter, like axions, exploit conversion to photons in strong magnetic fields, the Primakov effect. The Axion Dark Matter Experiment, ADMX, at the University of Washington uses tunable microwave cavities to resonate with axion frequencies in the galactic halo. Challenges include minimizing backgrounds, such as neutrons, radon, and achieving sensitivity for low-mass candidates. No definitive detections yet, but limits constrain models. Direct detection, probing particle interactions on Earth. Direct detection experiments aim to observe rare collisions between dark matter particles passing through Earth and detector materials. These setups are typically located deep underground to shield from cosmic rays and other backgrounds, focusing on elastic scattering events where dark matter imparts energy to atomic nuclei or electrons. Techniques vary based on the dark matter candidate's nature: bosonic or field-like, oceans and air, or fermionic, particle-like, W and I. Cryogenic crystal detectors use supercooled germanium or silicon crystals around 50 millikelvin to measure lattice vibrations, phonons, from dark matter interactions. Changes in surface resistivity detect these events. The cryogenic rare event search with superconducting thermometers, CREST, at Italy's Gran Sasso National Laboratory has operated since 2000, with iterations probing WIMP masses down to 160 MeV/c squared. Noble gas scintillators, liquids like xenon or argon, scintillate, emit light upon energy deposition. Photomultiplier tubes capture this light, and electric fields help reconstruct events, distinguishing nuclear recoils, potential dark matter signals, from electronic recoils, backgrounds. The Xenon series at Gran Sasso exemplifies this. Xenon 1T, 3.2 tons of liquid xenon, set a cross-section limit of 4.1 times 10 to the negative 47 centimeters squared for 30 GeV/c squared WIMPs, while Xenon NT 8 tons targets 1.4 times 10 to the negative 48 centimeters squared for 50 GeV/c squared. The LUX-ZEP-LIN experiment also uses xenon for detection. Crystal scintillators combine crystal vibration detection with scintillation. The Dama/Libra experiment at Gran Sasso searches for annual modulation in dark matter flux due to Earth's orbit through the galactic halo, though its claimed signal is debated as possibly seasonal artifacts. The SABRE project tests this in dual hemispheres, Italy and Australia. Bubble chambers, superheated liquids, freon droplets in gel, form bubbles from particle interactions. The PICO experiment at Canada's Snow Lab uses large chambers up to 500 liters planned to detect nuclear recoils, helping rule out certain interpretations of other experiments' results. Axion-specific detectors for ultralight bosonic dark matter like axions exploit conversion to photons in strong magnetic fields, the Primakov effect. The Axion Dark Matter Experiment ADMX at the University of Washington uses tunable microwave cavities to resonate with axion frequencies in the galactic halo. Challenges include minimizing backgrounds, such as neutrons, radon, and achieving sensitivity for low-mass candidates. No definitive detections yet, but limits constrain models. Direct